From the fantastical creatures in animated films to the interactive environments in video games, 3D computer graphics have revolutionized the way we experience the world around us. 3D graphics use computer software to create three-dimensional representations of objects and environments. This technology has become an integral part of various industries, including entertainment, gaming, architecture, product design, and more. 3D graphics allow us to visualize and manipulate objects in ways that were once unimaginable. We can create realistic representations of the real world or let our imaginations run wild with fantastical creations. The possibilities are limitless. The impact of 3D graphics on our lives is undeniable. From the films we watch to the games we play, 3D graphics have become an inescapable part of our visual landscape. They have blurred the lines between reality and fantasy, transporting us to new worlds and expanding our creative horizons. As technology continues to evolve, we can expect even more immersive and awe-inspiring experiences from the world of 3D graphics. The future holds endless possibilities for this dynamic and ever-evolving field. Animation is the art of bringing static images to life. It involves creating the illusion of movement by displaying a sequence of slightly different images in rapid succession. In 3D animation, these images are three-dimensional models that have been manipulated over time to create the desired motion. Keyframe animation is a fundamental technique used in 3D animation. It involves setting specific points in time called keyframes, where the animator defines the position, orientation, and other attributes of an object. The software then interpolates the movement between these keyframes, creating a smooth and continuous animation. Tweening, short for in-betweening, is another essential animation technique that complements keyframing. It involves automatically generating the intermediate frames between two keyframes, saving the animator time and effort. Tweening is particularly useful for creating simple movements such as linear translations or rotations. Easing, also known as animation curves, allows animators to fine-tune the timing and speed of an animation. By adjusting the easing curves, animators can create more realistic and visually appealing movements. For instance, they can make an object accelerate gradually at the beginning of a movement and decelerate smoothly at the end, mimicking the physics of real-world motion. Underlying all animation techniques are the fundamental principles of animation, as outlined by Disney animators Ollie Johnston and Frank Thomas. Visual effects, or VFX, play a crucial role in enhancing the realism and visual impact of films, video games, and other media. 3D graphic software provides a wide range of tools for creating stunning visual effects that mimic real-world phenomena. Particle simulations are used to create effects that involve a large number of small particles, such as smoke, fire, explosions, and dust. The software simulates the behavior of individual particles such as their position, velocity, and color based on physical laws and user-defined parameters. This results in realistic and visually captivating effects that would be difficult or impossible to achieve using traditional methods. Dynamic simulations involve simulating the movement and interaction of objects under the influence of forces such as gravity, wind, and collisions. This technique is used to create realistic cloth simulations, hair movement, water ripples, and other effects that involve complex physical interactions. By accurately simulating the behavior of these elements, artists can create incredibly lifelike and believable visual effects. 3D graphics software also allows for simulations of other natural phenomena, such as fire, smoke, explosions, and destruction. These simulations use complex algorithms to create realistic-looking effects that interact with the environment and other objects in the scene. Game development relies heavily on 3D graphics to create immersive and interactive game worlds. From character models and environments to special effects and animations, 3D graphics are essential for bringing video games to life. Game engines are software frameworks that provide developers with a comprehensive set of tools for creating video games. They typically include features such as a rendering engine for graphics, a physics engine for simulating physics, a sound engine, and tools for scripting gameplay logic, artificial intelligence, and networking. 3D modeling is a fundamental aspect of game development, allowing artists to create the characters, objects, and environments that populate the game world. Texturing involves adding colors, patterns, and details to 3D models, making them visually appealing and realistic. Lighting is crucial for setting the mood and atmosphere of a game environment. Animators bring characters and objects to life, while rigging involves creating a skeletal structure for 3D models to enable realistic movement. Programming is essential for implementing gameplay mechanics, artificial intelligence, and other game logic. Design encompasses the overall creative vision of the game, including its gameplay, story, and aesthetics. Section 5. Lights, camera, action, the stages of film and animation production. The production of animated films and visual effects-heavy blockbusters involves a complex and multifaceted pipeline, typically divided into 3 main phases: pre-production, production, and post-production. Pre-production is the planning stage, where the story is developed, the script is written, concept art is created, and the overall visual style of the film is established. Storyboarding is a crucial part of pre-production, involving creating a visual representation of the film's narrative through a series of illustrations. Animatics are then created by adding basic sound effects and dialogue to the storyboards, providing a rough draft of the film's timing and pacing. Production is the phase where the actual animation, modeling, texturing, lighting, and rendering take place. Animators bring characters to life, environments are built, and visual effects are created. This stage requires close collaboration between various departments, including animation, modeling, rigging, texturing, lighting, and rendering. Post-production is the final stage, where the animated sequences, visual effects, sound design, music, and editing are all brought together. This phase involves compositing the different elements of the film, color grading, adding special effects, and creating the final sound mix. Section 6. Blueprints to Reality 3D graphics in architecture and design. 3D graphics have revolutionized the fields of architecture and product design, providing architects, designers, and clients with powerful tools for visualization, communication, and collaboration. Architects use 3D modeling software to create virtual models of their designs, allowing them to visualize the spatial qualities of a building before it is built. Texturing and lighting bring these models to life, simulating different materials, lighting conditions, and times of day. Rendering software allows architects to create photorealistic images and animations of their designs, providing clients with a clear understanding of the final product. These renderings can be used for presentations, marketing materials, and client approvals. Product designers use 3D modeling software to create digital prototypes of their designs, allowing them to visualize and test different shapes, forms, and materials. They can create realistic renderings of their products, showcasing their aesthetics and functionality to potential customers and investors. Animation can be used to demonstrate how a product works, highlighting its features and benefits. Section 7. Your toolkit awaits essential software for 3D graphics. A wide range of software is available for creating stunning 3D graphics, each with its strengths and weaknesses. Here are a few popular options. Blender is a free and open-source 3D graphics software suite that has gained immense popularity for its versatility and powerful features. It offers a comprehensive set of tools for modeling, texturing, lighting, animation, and rendering, making it an excellent choice for both beginners and professionals. Maya is a professional 3D graphics software developed by Autodesk. It is widely used in the film and game industries for its advanced animation, modeling, and rigging tools. Maya also offers powerful dynamics and simulation capabilities for creating realistic visual effects. Unity is a cross-platform game engine developed by Unity Technologies. It is known for its user-friendly interface, extensive documentation, and large community support. Unity supports a wide range of platforms, including PC, Mac, mobile devices, web browsers, and game consoles, making it a popular choice for independent game developers. Section 8. A glimpse into the future, trends and advancements in 3D. The field of 3D graphics is constantly evolving, driven by technological advancements and the pursuit of ever more realistic and immersive experiences. Several trends are shaping the future of 3D graphics. Real-time rendering technology is rapidly improving, allowing for the creation of stunningly realistic graphics that can be rendered and displayed instantly. This has significant implications for video games, virtual reality, and augmented reality, where real-time performance is crucial. Virtual reality (VR) and augmented reality (AR) are becoming increasingly sophisticated, creating immersive experiences that blend the digital and physical worlds. 3D graphics are essential for creating believable and engaging VR and AR experiences. Artificial intelligence (AI) is being integrated into 3D graphic software, automating tasks, assisting artists, and enabling new creative possibilities. AI-powered tools can generate textures, optimize models, and even create animations, freeing up artists to focus on higher-level creative tasks. Section 9 Conclusion. The ever-evolving landscape of 3D graphics. 3D computer graphics have revolutionized the way we create and experience visual content. From entertainment and gaming to architecture and product design, 3D graphics have become an indispensable tool across numerous industries. As technology continues to advance, we can expect even more realistic, immersive, and awe-inspiring 3D graphics experiences in the years to come. Whether it's the breathtaking visual effects in films, the immersive worlds of video games, or the innovative designs in architecture and product development, 3D graphics will continue to shape our visual landscape and inspire our imaginations.